We're going to do this in terms of transformations for both of them. Part A is a line. The y-intercept is, the slope says 2. So notice that's the ordered pair, 0, -2, and the ordered pair 1, 1. Now, you can eyeball these, but it's easier if you do have some ordered pairs as a point of reference here. So in green there is the original function f. In blue, I'm going to graph the inverse. If the original function sends 0 to -2, what does the inverse do? -2 goes to 0. If the function sends 1 to 1, what does the inverse do? 1 to 1. 2 points make a line. So in blue is the graph of the inverse. And again, you should see a nice mirror image about the line y equals x. So it should look like it flipped over that line. One comment I want to make is notation. This symbol is pronounced F inverse. It is not the reciprocal of F. When you have a negative on a -1 exponent, quote unquote, on a function, it means inverse. If you have a -1 exponent on a number, that means reciprocal. So 2 raised to the -1 means 1/2. But f, what looks to be raised to the -1, means f inverse. All right, part B. We're going to transform a cubic function. How are we going to transform the cubic function? We're not solving for the variable. We're doing a transformation, which means you're telling me how it moves. So by subtracting 2 from the variable, write 2, and then adding 1 to the function. Up 1. So our origin was the center, but by moving right 2 up 1, then the point 2, 1 is the center. Oh, that was terrible. I'm going to do that again. Should have stuck with, that one's okay. I'll allow it. So, I want you to try to sketch the inverse. If the original function goes through 2, 1, then the inverse is going to go through 1, 2. Also, if you need to, draw on the line y equals x. And use that as a mirror image. So this guy, your answer should look, oh, yeah, that's the right color. Something like that. So it should look like a mirror image. This moves over here, this moves over here, this moves over here, so on and so forth. It's in green.